Hey AI enthusiasts! Let's start this AI simulation adventure with a field that's absolutely exploding with activity: robotics and autonomous vehicles. Remember those clunky, pre-programmed bots of yesteryear? Well, forget them. We're in a new era now, an era of AI-powered robots that are not only nimble and adaptable but also remarkably intelligent. Companies like NVIDIA are using their Omniverse platform. Think of it like a massive virtual reality playground for robots, to create realistic simulations that these robots use to learn and refine their skills. Imagine robots mastering complex tasks like surgical procedures or navigating demanding terrain in hazardous environments, all within the simulated environment before any real-world operations. And it's not just about robots in the factory either. This virtual training is accelerating development of autonomous vehicles, like self-driving cars, enabling them to safely and efficiently navigate traffic like self-driving cars. It's remarkable efficiency. NVIDIA claims that its Isaac Sim now allows AI to train at a rate of 20 billion miles driven a year from simulations. That translates to billions spent less testing in the real world. Talk about a game changer, as these AI-driven simulations save tons of money and, importantly, time. The possibilities are almost without bounds. Think of the implications for logistics, construction, and so on. The speed that we are training and deploying robots is only going to continue its exponential growth. We're entering a realm where everyday tasks, from household chores to warehouse management, could be expertly handled by self-learning robots, making our lives remarkably easier. Let's take a closer look at the technology that's fueling this incredible progress. NVIDIA's Omniverse is becoming the game changer here. Why? Because it offers a sophisticated, unified platform for setting up, doing, and analyzing physically realistic simulations that include all the necessary physical aspects that make simulation realistic. Isaac Sim, NVIDIA's reference application built upon Omniverse, is especially important for training and testing AI-driven robots in realistic 3D virtual environments. Picture this: a virtual warehouse, complete with all the goods, equipment, and robots, but entirely simulated. Using Isaac Sim, the AI can practice navigating around obstacles, lifting and moving boxes, picking up items, working around obstacles in thousands of virtual scenarios before heading into a real environment, which is not only more efficient but drastically safer. They've recently taken things even further by enabling access to Isaac Sim using Amazon's EC2 instances and by using high-performing NVIDIA L40S GPUs, allowing anyone, without prohibitive infrastructure costs, to scale their robotics training and testing. Using this capability, you can also easily generate enormous quantities of synthetic data using tools like Omniverse Replicator, creating custom synthetic data generation (SDG) pipelines using generative AI, which can then boost both the accuracy, speed, and versatility of your AI models to ensure that robots are as effective and robust as possible, further accelerating the development and deployment of AI-driven robots and solutions. It's democratizing development, and everyone can get in on the action. Now, let's shift gears and explore another fascinating area where AI simulation is making a real difference: healthcare. Simulation is crucial for medical education because it allows healthcare professionals to train and hone their skills without risking patient well-being. Simulation technologies are helping to improve all aspects of clinical training. AI takes this to an entirely new level by personalizing the scenarios with an unprecedented level of fidelity to realistic patient responses, creating an adaptive learning experience tailored to each student's needs. Imagine medical students practicing complex surgical procedures like laparoscopic surgery or robotic surgery, receiving real-time feedback on their performance. AI can simulate virtual patients that deliver realistic responses, modeling patient reactions, and presenting data points for diagnosis and suggesting potential treatment options. Using this approach enables the assessment of decision-making skills in situations ranging from commonplace diseases to rare conditions. In this way, AI simulation is not only a way to enhance medical training, but a way to improve outcomes and reduce medical errors, making the delivery of healthcare safer and patient-centric. The need of upskilling healthcare providers and having a strong focus on patient safety are driving higher adoption across the globe, so that the need of quality training is never more important, especially in the context of emerging pandemics. Generative AI is also bringing some really incredible advancements to healthcare beyond just simulation. It's revolutionizing the field by creating synthetic medical data that's identical to real data. The advantage? Being able to analyze such synthetic data allows professionals to bypass some of the limitations of real-world datasets. For example, medical institutions can now train AI-powered diagnostic instruments and enhance medical image analysis, improving diagnoses without jeopardizing patient confidentiality especially for rare and previously untreatable illnesses. Generative AI can help build personalized treatment plans that meet an individual's genetic and physiological needs. Moreover, it dramatically helps accelerate drug discovery and development, streamlining workflows, which is not only faster but potentially a vastly cheaper process to help the patient quickly. You could probably even imagine a day, very soon in the coming future, when this is not only commonplace, but that developing new medicines without leveraging such technology would just be illogical and impractical. What a shift! Let's talk about a truly impressive achievement in precision. SimBig, a groundbreaking AI system developed by researchers at the Flatiron Institute. This remarkable tool uses AI to estimate the universe's cosmological parameters with a level of precision never before achieved. SimBig delves deep into galaxy data and extracts hidden insights that can refine our understanding of the cosmos, from dark matter and dark energy to the very origins of the universe after the Big Bang. The accuracy of SimBig's insights is impressive, aligning closely with measurements of the universe's earliest light. Imagine the implications for our knowledge of fundamental physics, the expansion of the universe, and the vast mysteries still left to be uncovered. It's making a substantial contribution to cosmology, a subject that has for a very long time been constrained by limited observations. It leverages 2,000 simulations and only needed this low number of simulations thanks to AI. Imagine that. Without AI, it would require hundreds of thousands. This level of precision has even impacted the famous Hubble tension, a discrepancy in how scientists measure the universe's expansion rate. SimBig's improvements will help researchers better explore the Hubble tension and refine our understanding of the universe's expansion rate. If its refinements resolve the tension, great. If not, it will give us clues to something entirely new. It's reshaping how we even approach these problems. Another stunning example of AI simulation's power comes from the NVIDIA's Cosmos platform. This isn't just any simulation. They're calling it a multiverse simulation platform, meaning that Cosmos generates all types of videos based on real-world data, simulating every possible outcome in a particular scenario. It's really a radical jump forward in terms of generating new training data. Using diffusion models and autoregressive models, Cosmos can ingest text, images, or videos to create an enormous amount of synthetic footage, letting scientists rapidly produce vast datasets for AI and machine learning training. This is truly democratization of an approach previously out of reach for most, opening numerous opportunities for training advanced AI systems, like those needed for control of autonomous vehicles or humanoid robots, all by leveraging the capabilities in generative AI. Imagine that. Self-driving algorithms that have been trained via simulations will therefore have already dealt with thousands of hypothetical scenarios, driving billions of miles within simulation before ever encountering one in real-world applications. But it goes beyond driving. The open-source access is driving innovations in robotic design, allowing developers to see how robots might behave in a wide range of conditions as they prepare to ship their products while mitigating cost and risk and accelerating the timeline to deployment. It's incredible. Let's be honest. Training robots is an expensive, time-consuming, and complex endeavor. Until recently, it took enormous resources and many iterations, sometimes using human-controlled robots and often resulting in damage to robots or equipment. But here's something that could change things completely. Genesis, the revolutionary open-source computer simulation system developed by a research team at Carnegie Mellon University and industry partners. Genesis allows for the testing and training of robots 430,000 times faster than real time. The platform utilizes advanced GPUs to simulate virtual worlds for testing and training robots, using physics calculations up to 80 times faster than existing simulators. It is designed to operate high-fidelity simulations at enormous scales, simulating up to 100,000 independent copies at once. The team even announced they are working on generating 4D dynamic worlds, using vision language models, VLMs, to simulate scenarios based on text descriptions or image inputs. Imagine that, using only text or images, you can fully simulate an environment complete with dynamics for AI-based training. With Genesis, you can create limitless scenarios to train robots with unparalleled efficiency. This capability to perform efficient, high-fidelity training at enormous scales is what could soon deliver highly effective embodied robots into factories, homes, and anywhere else we might need them. How could that not be exciting? Training robots in simulation is beneficial and has become commonplace, however. Relying solely on simulations can frequently lead to unexpected problems when transferring algorithms to real-world systems. This is because simulations are models and approximations of reality, a problem often referred to as the reality gap. To address the reality gap, researchers at the University of Washington have developed two groundbreaking AI systems called Rialto and URD-Former. Rialto, in particular, uses video and images captured with a smartphone to create a realistic digital twin of an environment, such as a kitchen. The robot can then learn to complete tasks such as opening a refrigerator or toaster in simulation. In the digital twin, it is possible for users to instruct the robot to make changes, such as adding objects to the environment or placing a mug near a toaster. Interestingly, transferring that learned behavior to a real kitchen has almost the same accuracy as training the robot in the real kitchen itself. Another key advantage of Rialto is that it is efficient. The process learns how processes operate from only video or images and a minimal amount of additional prompts provided by the user, and this approach has proved superior to other techniques. Meanwhile, URD-Former uses images from the internet to quickly create simulated environments, though with less precision than Rialto. These two approaches complement each other, highlighting how simulation with generative AI is transforming the landscape of robotics. While URD-Former provides a way to pre-train at low cost, Rialto focuses on bringing highly accurate simulations to specific environments at lower cost than traditional methods, making robots more adaptable, efficient, and safe for use in homes and businesses. Humanoid robots are on the verge of becoming a reality, but building them poses enormous challenges. To tackle this, NVIDIA has launched Project GR00T, a powerhouse of resources aimed at propelling the development of humanoid robots. Project GR00T provides a variety of resources for humanoid developers including libraries, AI models, and data pipelines. It also offers 6 new workflows: GR00T Gen, GR00T Mimic, GR00T Dexterity, GR00T Control, GR00T Mobility, and GR00T Perception to simplify the design, implementation, and training of humanoid robots, building simulations in OpenUSD, and generating massive amounts of synthetic data for robot learning. These capabilities are intended to help with perception, motion, and dexterity that will allow humanoids to function in real-world scenarios. The release underscored the significance of these advancements within the development workflow. Generative AI, combined with NVIDIA's Isaac Lab platform, allows training humanoid policies at scale, handling the complexity of motion across diverse terrains. NVIDIA also showcased Mask Mimic, an AI framework to reconstruct highly realistic human motion and generate a wide range of motions across diverse terrains, greatly advancing humanoid robot development through simulation and testing protocols. By open-sourcing tools and processes, Project GR00T is removing barriers to entry and fostering collaboration amongst the global roster of developers involved in this effort. What better way to accelerate progress towards building effective humanoids? Let's address the elephant in the room: data. Training AI systems requires vast quantities of high-quality data. Gathering real-world data is often expensive, time-consuming, and ethically challenging. While it is possible to leverage data gathered from the internet, such data could be biased and not representative of certain groups. This is where synthetic data generation is becoming more and increasingly important in training the next level of AI systems. By creating realistic digital twins and using OpenUSD to connect it all, developers can generate synthetic data to train AI models for diverse fields, from robotics and autonomous vehicles to healthcare and even cosmology. Simulation models are able to not only provide data in enormous quantities, but allow the evaluation of scenarios and conditions never before possible, while being significantly less expensive than working with real-world data. It's a game changer. You can also introduce different degrees of randomness, using techniques like domain randomization to improve the robustness. It's eliminating the need for extensive data collection and is dramatically driving speed in model training. Companies like NVIDIA are leading the charge, building platforms like Omniverse and Isaac Sim. Its use and impact is only going to continue its exponential growth. You can even think of it like this: the same principles are now being used to train AI for nuclear simulation and predict protein folding for drug discovery. We're not just talking about robots here, but a vast array of AI-enhanced capabilities across scientific disciplines. It's absolutely amazing. While AI simulation is clearly revolutionizing many industries, there are still significant challenges. One of the biggest is the simulation-to-reality gap. Simulations are models of the real world, and these models inherently simplify or abstract aspects of reality. This gap can lead to inaccuracies in training AI since it is learning from imperfect data, therefore, necessitating care in the design and validation of simulations. Then, there is the problem of obtaining trust in AI systems. We need to assure the safety, reliability, and trustworthiness of AI, and methods to evaluate the models must be developed and implemented. Furthermore, there are legal and ethical concerns related to data privacy, security, algorithm bias, and even job displacement that need to be explored and addressed. But this is only natural in the advent or the expansion of any new powerful technology. The work done by the AI research community is only going to become more important in developing the legal, ethical, and theoretical frameworks as this powerful new technology continues to evolve. One key step will be to improve our ability to interpret and explain AI models, creating more transparent systems that users and stakeholders alike can fully comprehend and trust. We believe hybrid approaches, integrating AI models with traditional simulations and data-driven insights, offer the most promising path to fully unlocking the potential of these technologies. By embracing both AI's power and physical world's laws and harnessing the ever-expanding open-source ecosystem's contributions, we can make more progress toward a future where AI and simulation can help address humanity's greatest challenges.